Good day everyone, my name is Firdavs Muhammadjonov and welcome to our discussion on quality attribute analysis in microservice architecture. Today we are diving into the role of microservices, exploring how this architectural paradigm impacts various quality attributes which are crucial for building scalable, robust and maintainable software systems. In this journey we will embark on 5 case steps. First, we will establish a solid foundation by understanding the core principles and benefits of microservice architecture. We will highlight several key quality attributes such as scalability, maintainability, and resilience. Then, next up, we'll look at the real examples of how microservices are used in the real world. We'll check out different types of software setup to see how they use microservices to make things better. This will give us a good understanding of how microservices can be helpful in different situations. Then we'll take what we have learned and really look closer at how microservices actually works. We'll break down different parts of how they set up, such as how they talk to each other or how they handle different information. By doing this, we will see how these things impact how the system works overall. After all, we'll compare microservices with other way of building software system to see which one is better. Last, we'll wrap our exploration with a practical tip. First, we'll summarize all information that we have passed so far, about how impact of software, about the impact of microservice architecture and quality attribute. Then I will provide architectures and developers some practical tips with some helpful tips on how to make sure their microservice-based architecture works really well. But first, let's understand what microservice architecture is. Microservice architecture is like having a big task and breaking down to smaller, more manageable jobs. Each small job on microservice, we can say, handles specific part of the task. These microservices will work together like building blocks for creating a larger complex system, more complex system. Think of it as a team of specialists working together, each focusing on their own expertise to get the job done efficiently. This approach makes it easier to develop, scale, and update software systems comparing to the traditional monolithic architecture where everything is tightly connected with each other. Now we're ready to start our exploration talking about first step. In this part, we will lay foundation by understanding the core principles and advantages that underpin this approach to building software system. We'll delve into why this approach is so effective for creating scalable and maintainable systems. Additionally, we'll identify key quality attributes such as scalability, resilience, and maintainability, which are crucial for ensuring the success of microservice-based architecture. Firstly, let us discuss the principles that underpin microservice architecture. Picture a large monolithic system as a giant puzzle. Microservice architecture breaks down this puzzle into smaller, more manageable pieces through decomposition. Each piece or service, we can say, operates autonomously like individual things. This autonomy enables faster development and deployment, fostering a culture of innovation and agility. Moreover, resilience is a key principle, ensuring that failure in one service does not break down the entire system. Finally, another principle is microservice architecture offers flexibility, allowing for the independent scaling and updating of services without disrupting the entire system. Now, let's explore the benefit of microservice architecture. Scalability is one of the advantages, as it enables us to scale individual services independently based on demand. Furthermore, maintainability is significantly enhanced due to the smaller, focused nature of microservices. This makes it easier to identify and fix issues. Additionally, fault isolation ensures that issues in one service are contained, minimizes their impact on other parts of the system, and maintaining overall system stability. We need to shift our focus to the key quality attributes that are essential for evaluating the success of microservice architecture. Scalability remains important, as the ability to handle increased workload ensures that our system can grow alongside our business needs. Resilience is another critical attribute, ensuring that our system can recover from failures and continue operating without significant disruption. Maintainability is also a key, and the ease of maintaining and updating services ensures that our system remains agile and adaptable to changing requirements. And lastly, performance is crucial for ensuring the efficiency and responsiveness of both individual services and the system as a whole. Now that we've grasped the basic of microservice architecture, it's time to dive deeper into real-world examples. In these steps, step number 2, we'll explore a variety of case studies showcasing software systems that have embraced microservice architecture. By examining these real-life examples, we can gain valuable insights into how microservices are implemented and their impact on different types of systems. We'll make sure to include a range of architectural styles and quality attribute goals, allowing us to see the effectiveness of microservices in action. Now, let's talk about two big companies, Shopify and Netflix. They both use something called microservices to make their websites and applications work really well. First, I will start with Shopify. Shopify is an online store, uses microservices to handle things like letting you sign in, adding products to your cart, and paying for your purchases. They break these tasks into smaller parts, like pieces of puzzle, so everything works smoothly. By decomposing the platform into smaller modular components, Shopify enhances the scalability, flexibility, and resilience. This architecture enables Shopify to scale its platform horizontally to handle spikes in traffic, experiment with new technologies more easily, and isolate failures to prevent widespread disruptions. Netflix. Netflix, the streamlined service, also uses microservices. They have different services for things like suggesting shows, keeping track of what you have watched, and taking the video to your screen based on recommendation. Each of the services does its own job, but they all work together to give you a great experience. This approach allows Netflix to scale its platform dynamically, ensuring optimal performance and responsiveness even during peak usage periods, like peak loads. By breaking down its platform into smaller, manageable components, Netflix enhances, improves resilience and fault tolerance, ensuring uninterrupted streaming experiences for users worldwide. Additionally, microservices enable Netflix to innovate rapidly, experiment with new features, and adapt to evolving user preferences, solidifying its position as a leader in the streaming industry. We can say that in the summary of this part, these case studies showcase how microservices architecture is applied in different domains and highlight the varied architectural styles and quality attribute goals that can be achieved through its adoption. Both Shopify and Netflix demonstrate the power of microservice architecture in achieving quality attribute goals such as scalability, resilience, maintainability, and performance. Now we're delving into the heart of our study, quality attribute analysis for microservices. Imagine microservices as a piece of puzzle that make up our software. But just like fitting puzzle pieces together, like combining them, we need to understand how each part affects the overall picture. In this step number 3, we'll take a closer look at how different aspects of microservice architecture, like how they split up, how they talk to each other, and how they manage data, affects the quality of our software. We'll use some smart techniques to analyze these pieces and see how they balance important qualities like speed, reliability, and flexibility. Let's begin by discussing the impact of service decomposition. By breaking down into smaller independent services or microservices, we can achieve significant improvements in scalability, maintainability, and resilience. Each microservice focuses on specific tasks, making it easier to scale individual components as needed and update them without affecting the entire system. This decomposition enhances our system ability to grow with demand, adapt to changes, and recover quickly from failures. Next, let's talk about communication patterns in microservice architecture. Communication is the key in a system, and microservices are no exception. We use various communication patterns like synchronous and asynchronous communication and message queues to facilitate interaction between services. These communication patterns impact crucial quality attributes such as performance, fault tolerance, and scalability. And here it's time to dive into data management in microservices. Microservices handle data management differently, with each service managing its own its own storage and database choices. Like each how to say each part of our program, like microservices, own their own data storage, and this decision impact the overall quality attributes of our system. For example, choosing a distributed database allows for better scalability but may introduce complexities in maintaining data consistency. By understanding how data management strategies affect and impact quality attributes, we can make informed decisions to optimize our system performance and reliability. And now it's time to talk about trade-off and consideration involved in optimizing quality attributes within microservice architecture. As we progress to achieve scalability, resilience, and maintainability, we must navigate various trade-offs and considerations. This includes balancing the complexity of implementation with the desired quality attributes, optimizing the resource utilization without sacrificing performance, and understanding the impact on development speed. While microservices offers numerous benefits, it's essential to weigh these trade-offs carefully to ensure that our architectural decisions align with our overall goals and priorities. Welcome to the fourth step of our exploration, comparison of architecture styles. We are going to talk about different ways to build software. One of the popular ways is called microservices, but there are also other ways like making everything into one big piece, like monolithic, using no setup at all, like serverless, and organizing things around events, event-driven architecture style. And they're also living in containers, container-based architecture. We'll compare these methods to see which one might be the best fit for different projects. So let's get started and explore the difference between microservices and other way of building software. When comparing microservices and monolithic architectures, it's essential to consider their respective strengths and weaknesses. Microservice architecture offers a modular and scalable approach, allowing for greater flexibility and resilience. By breaking down an application to smaller, independent services, microservices enables teams to work on different components simultaneously, leading to a faster development cycles and user scalability. Additionally, we can also say that microservices provide a better fault isolation, and the failure in one service typically does not impact the entire system. However, managing communication between services and ensuring data consistency can be challenging, adding complexity to the architecture. On the other hand, monolithic architecture provides simplicity and ease of development. With all components tightly integrated into a single unit, monolithic applications are often easier to deploy and maintain. However, monolithic architecture may struggle with scalability and fault tolerance. And the scaling the entire application can be inefficient, and a failure in one component can break down the entire system. Despite its simplicity, monolithic architecture may become cumbersome and difficult to manage as the application grows in size and complexity. In contrast, there is also another architecture style known as a serverless architecture that abstracts away the underlying infrastructure, allowing developers to focus only on writing the code without worrying about server management. This approach offers benefits in terms of code efficiency and scalability, as the resources are not only consumed when the code is executed. However, there are potential drawbacks to consider. Serverless architecture may introduce latency, and there can be a delay in spinning out the resources to execute code, and also developers may encounter a limitation in terms of resource availability, such as memory or execution time constraints imposed by the cloud provider. And next, another architecture style that I want to talk about is called event-driven architecture. Event-driven architecture relies on events to trigger and communicate between different components of application. This approach enables asynchronous communication, better decoupling between services, making it well suited for handling unpredictable workloads and complex workflows. However, managing event streams and ensuring message reliability can be challenging, as the developers need to implement mechanisms for event processing, routing, and error handling to maintain the system integrity. And finally, we have reached the final step of our journey, conclusion recommendations. In this step, we'll bring together all the insight we have gained about how microservices architecture affect the quality of software. Think of it as summarizing the highlights of our adventure, but we'll not stop there. We'll also provide practical recommendations for architects and developers on how to make the most of microservice-based system. So as we conclude our exploration, equipped with available insights, let us prepare for the next step in software development with a confidence and determination. And let's start with a summary of our journey. Microservices are like a building block, as I said, for software, making it easier to build and maintain big programs. That let us work on different parts of a project at the same time. And if one part breaks, it doesn't mess up the whole thing. Compared to the other ways of building software, microservices are good because they're flexible and can handle a lot of users at once. But they can be a bit tricky to set up and manage, especially when it comes to making sure all the parts talk to each other correctly. When it comes to designing and implementing microservice-based systems to optimize quality attributes, architects and developers should start by establishing a clear architecture. This involves defining distinct boundaries for each microservice, aligning them with specific business domains or functionalities. And when making microservices, it's important to think about scalability and resilience. Scalability means the system can handle more users on work when needed. So architecture and developers should design services so they can grow easily and by adding more of them when lots of people are using this system. Also, it's crucial to make the system resilient. This means adding things like retries, circuit breakers, or fallbacks to handle any problems that might happen, so the system keeps working without interruptions. And while building microservices, how they talk to each other is really important. Architectures and developers should pick the right ways for them to communicate, like using messaging or events, so they don't rely too much on each other. This helps the system be more flexible and able to handle more work using things like APIs and message queues for communication that make sure everything works smoothly and help prevent problems from spreading across the whole system. Following these suggestions helps make sure microservices work well, are strong, and are easy to keep up to date with what modern software needs. In a conclusion, our research journey into quality attribute analysis in microservice architecture has provided valuable insights into the intricacies of modern software development. Through our exploration, we covered the principles and the benefits of microservice architecture, recognizing its important role in building scalable and maintainable systems. By delving into case studies like Netflix and Shopify, we have gained a comprehensive understanding of real-world application of microservices. Our in-depth analysis of how different aspects of microservice architecture impact quality attributes, coupled with the performance measurement comparison against monolithic and other architecture styles such as event-driven architecture or serverless architecture, has shed light on the strengths and the trade-off inherent in this approach. As we progress, it's clear that the microservice architecture offers immense potential for optimizing quality attributes such as scalability, resilience, and maintainability. Moving forward, our recommendation for architectures and developers emphasize the importance of thoughtful design and implementation practices to harness the full potential of microservice-based system. With this insight and recommendations in mind, we'll embark on the next phase of software development armed with the knowledge and tools to create robust and adaptable systems that meet the evolving needs of digital landscape. And thank you for your attention. This is all for this research content covering the topic of quality attribute analysis in microservice architecture, and hope to see you in the upcoming videos. Bye and have a nice day.